Welcome to our practical guide on creating and editing charts in IBM SPSS statistics. This presentation is designed for students and researchers looking to master the transition from raw data to powerful visual insights. We will cover the entire workflow, from choosing the right chart type to customizing and exporting your final graphics for publication. Raw data is overwhelming. Effective visualization converts complex data sets into immediate economic narratives. Graphs are processed 60,000 times faster than text. Information presented in graphs is easy to comprehend and analyzed quickly compared to texts. Source: An Introduction to Data Analysis. This slide presents the core decision logic for choosing the right chart type, emphasizing that you should never guess. The process begins by asking, what is your variable type? You must match the chart type to your data's level of measurement, whether it's nominal, ordinal, or scale, before you even open the software. If you have a single variable that is categorical or nominal, such as gender or region, the appropriate charts to use are a bar chart or a pie chart to show frequencies or proportions. If you have a single variable that is continuous or scale, like salary or GDP, you should use a histogram or a box plot to understand its distribution. When dealing with two variables, the combination of variable types guides your choice further. If you have a nominal variable combined with a scale variable, such as comparing mean salary by gender, a bar chart of means is recommended. Lastly, if you have two scale variables, like income and expenditure, a scatterplot is the ideal choice to visualize their relationship and any potential correlation. The key takeaway is, don't guess. Understand your data's level of measurement first, then apply this logic to select the most appropriate visual representation. There's a fundamental principle in data analysis: garbage in, garbage out. If your data isn't set up correctly, your results, including charts, will be meaningless or simply fail to generate. Before opening the chart builder, you must go to the variable view in SPSS and correctly set the measure level for each variable as scale, ordinal, or nominal. This is absolutely critical. If you misclassify a variable, for example, defining a categorical variable like gender as scale, the chart builder will not work as expected and will likely produce an error. Imagine you're trying to create a bar chart showing a number of male and female participants. If you've incorrectly labeled the gender variable as scale, SPSS will try to calculate a mean or sum of gender codes, like 1 and 2, which is nonsensical, instead of creating distinct bars for each category. Once our variables are correctly defined, we can proceed to the main interface. SPSS offers a couple of ways to create charts, so let's look at the available paths. SPSS provides two primary methods for creating charts. The first is the modern, recommended approach, the chart builder. The chart builder uses a visual drag-and-drop interface, offering great flexibility and power for creating complex, publication-quality graphics. The second method is through the legacy Dialogs. This is an older, menu-driven system. While it can be faster for creating very simple, standard plots, it lacks the flexibility and customization options of the chart builder. For this presentation, we will focus exclusively on the chart builder, as it is the industry standard and the more versatile tool. If you need a quick, basic histogram, a legacy dialog might get you there in 3 clicks. However, if you want to create a clustered bar chart with error bars in custom colors, the chart builder is the only effective way to do it. Now, let's dive into the chart builder and get familiar with its workspace. The chart builder workspace is where you design and construct your charts. Think of the main area, labeled as 3, as your painting canvas. First, you'll find the variables list, labeled 1, on the top left. This is where all your available data variables are located, ready to be used. Below that, labeled 2, is the gallery, which provides various chart templates like bar charts, histograms, or scatterplots. You select your desired chart type from here. Once you've chosen a template from the gallery, you then drag your variables from the variables list onto the X and Y axes in the canvas area, labeled 3. This area gives you a live preview of your chart as you build it. Finally, on the right side, labeled 4, you have the element properties. This is where you can edit the statistics being displayed, customize appearance, and fine-tune other specific details of your chart. Bar charts are excellent for comparing differences between distinct groups. Our goal here is to compare the average job satisfaction, which is a scale variable, across genders, a nominal variable. After dragging the variables to the appropriate axes, the most critical step is to check the statistic being plotted. SPSS might default to count, which shows frequency. You must go into the element properties and ensure the statistic is set to mean. This tells SPSS to calculate and plot the average job satisfaction for each group, not just the number of people in each group. Scatterplots are the go-to tool for visualizing the relationship and correlation between two continuous, or scale, variables. Our goal here is to analyze the relationship between a person's income and their frequency of visits to a store. We would drag income to the x-axis and frequency of visits to the y-axis, as shown in the SPSS Chart Builder dialog. Once the plot is generated, you look for a pattern. Does the cloud of points slope upwards, suggesting a positive correlation? Or does it slope downwards, indicating a negative correlation? A random scattering of points suggests no relationship. If we plot income against frequency of visits, we might see that as income increases, the number of visits also tends to increase. This would appear as an upward-sloping pattern of dots, as indicated by the positive correlation arrow on the slide, illustrating a positive correlation between the two variables. Scatterplots show us relationships, but what if we need to understand the characteristics of a single variable? For that, we use histograms. Histograms are essential for understanding the distribution of a single continuous variable. Here, our goal is to check if the height variable follows a normal distribution. This is a crucial step in many statistical procedures, especially regression analysis, which assumes that the model's residuals are normally distributed. A key feature in SPSS is the ability to overlay a normal distribution curve, or a bell curve, on the histogram. You can enable this in the chart's properties. By comparing the shape of your bars to the bell curve, you can visually assess normality and identify issues like skewness, where the data is lopsided to the left or right. Box plots, also known as box and whisker plots, are incredibly powerful tools. Our goal here is to examine the spread of recall words across two different conditions. They provide a concise summary of a variable's distribution, showing the median, quartiles, and range. This makes them perfect for comparing the variance, or spread, between different groups. Most importantly, box plots are the best tool for spotting outliers. These are data anomalies, or extreme values, that appear as individual points or asterisks far away from the main box and whiskers of the plot. In the chart shown, we can see two box plots. The box for the mnemonic condition is higher, indicating a higher median recall. We can also clearly see a single data point, labeled as case number 6, that is an outlier, sitting far below the rest of its group. This immediately flags it for further investigation. Remember that the initial chart generated by SPSS is just a starting point, a draft. To prepare it for a report or presentation, you'll need to edit it. To do this, you must follow the double-click rule. In the SPSS Output Viewer window, you simply double-click on the chart you want to edit. This action opens a new, dedicated chart editor window. This new window contains all the tools you need to change colors, fonts, axis labels, titles, and much more. One of the most useful features in the chart editor for scatterplots is the ability to add a fit line. This adds a layer of statistical rigor to your visual analysis. A fit line, typically a linear regression line, visualizes the underlying trend in your data. This helps to confirm the direction, positive or negative, and strength of the relationship. You can also have SPSS display the regression equation, such as y equals 3.4x plus 12, and the r-squared value directly on the chart. The R-squared value tells you the proportion of variance in the dependent variable that is predictable from the independent variable, indicating the model's goodness of fit. The final step in refinement is customizing the aesthetics to ensure your chart is as clear as possible. This follows a simple select, edit, hide process. First, select any chart element, like an axis title. You'll see a gold frame appear around it. Second, edit that element using the Properties window that appears. Here you can change font sizes, styles, and colors to improve readability. Third, hide or delete any unnecessary elements that create clutter, such as redundant legends. The goal is a clean, easily understood visual. Remember, clarity is king. Increase font sizes for presentations and ensure access labels are descriptive. For example, annual income /sign, not just Inc_01. A chart is ultimately only as good as the insight it provides. Your job as a researcher is to interpret the visual and tell its economic story. Look at the key features. A downward slope, as seen here, indicates a negative correlation. The R-squared value indicates the explained variance, how well the line fits the data. The spread of the data points around the fit line indicates the correlation strength. Tightly clustered points mean a strong correlation, while widely scattered points mean a weak one. Always provide a caption or explanation that focuses on the insight. In this case, the clear economic story is that as age increases, the variable CFF decreases linearly. To maintain a professional standard, never use a simple screenshot to get your chart into a document. This results in low-resolution, blurry images. One good method is Copy Special. Right-click the graph in the SPSS output, select Copy Special, and choose Image. This allows you to paste a high-quality version directly into applications like PowerPoint or Word. For more control, use the Export function from the File menu. You can export the entire output document as a PDF or Word file, which embeds the graphics. Alternatively, you can choose to export only the graphics themselves as high-resolution image files like PNG or JPEG, giving you maximum flexibility for use in reports and publications. This slide summarizes the essential workflow for creating effective charts in SPSS. First, prepare your data by defining the measure levels in the variable view. Next, select the appropriate chart by opening Graphs and the Chart Builder. Then, build your chart by dragging variables to the axes and ensuring the correct statistics, like mean or count, are applied. Finally, refine your chart by double-clicking it to open the chart editor for editing and polishing. The key takeaway is to consistently follow this loop: structure, selection, construction, and refinement for every chart you create to ensure accuracy and clarity. Thank you for your attention to this presentation. We hope it has been insightful. Our mission at Dialogs is